Jeffrey Manthorpe back with you, Carleton University assistant chemistry prof, and we're having some fun.
Oh yeah.
Yeah. Once you're full prof, are you still allowed to have fun?
Absolutely.
Okay, good. There's a big event going on Saturday. 2 shows, 9 and 2:30.
11 and 2:30.
11 and 2:30, excuse me. Chemistry Magic, and we've been having some fun with it. So we made some elephant toothpaste, and we also saw ice cubes that sink, which is bizarre. What's up next?
Okay, so in here, let's make some color, shall we?
Okay, let's. Okay. Whoa. Okay, you asked me before we went on a long time ago what color would I like to see, and I said blue. I had no idea. How did that happen?
There's a dye in there, and what happens is it's...
Why didn't it react first?
Because it actually needs to react with oxygen from the air in order to turn blue.
So it was just sitting there, and then once you shook it,
there's enough
oxygen was put
oxygen
in.
there.
And now is it fading out again?
Yep.
And then would it go again if I shook it?
Absolutely.
So if I shake it again, we'll see a dark blue again?
Yep.
Whoa, that's so cool. I don't know what the practical application of it, but it's awesome.
That dye is actually currently being investigated for a treatment for Alzheimer's.
Oh my goodness, really? And
yes,
so this
really.
is where it comes down to. You talk about the different ways that chemistry branches into science, medicine, everything, right?
Yeah.
It's amazing.
Yep.
What are we looking at here?
Okay, so if you look at these, they look the same, right?
Yes.
And so it turns out that the centerpiece here is actually a carbon, and carbon can bond to 4 different things.
Okay.
Okay. Now, if you actually look at these, they're actually not the same.
This is a little shorter. This distance, is that what we're talking about?
No, if you look, they're actually a mirror image of each other.
Oh, you're right. They are opposites.
Okay, and we can't superimpose them over each other.
Okay.
Right? So just like your left and right hand. Right?
Gotcha.
So now molecules can exist with this property as well. So what I have here are 2 bottles of exactly the same compound, but left and right-handed.
Okay. Because they both say carvone, is that? Okay.
That's right. So take a whiff of that.
Yeah, it smells almost minty, or?
It's spearmint.
Spearmint, okay.
That's actually what's used as a spearmint flavoring. And this is the same molecule.
If I pass out, I'm going to be real mad.
Okay.
I'm just kidding. Oh.
And that's more of a caraway smell.
Yeah, that's right. I can still, there's still a hint of like a mint almost, but then it's a totally different smell though.
Yeah, absolutely.
And those are the same?
Yes, and it's because the proteins that make up our body are made up of amino acids, and each amino acid has this left and right-handed property.
Isn't that amazing? Wow, and we're talking about the smallest of small here as well. Okay, we've got, what have we got there? Is that dry ice in your hand?
We've got some dry ice, yeah.
By the way, don't handle it with just your hands, right?
Yeah.
Usually.
Gotta go
just
fast.
Be quick, right?
And what we have in here is a mixture of indicators, and when you mix dry ice with water, it actually produces carbonic acid. So this is exactly the same sort of effect you get by opening a Coke or some other soft drink.
Okay.
And the bubbles start to come out. So
is this because it's changing from a solid to a gas immediately?
Yes.
Okay.
Yeah, so dry ice is an interesting compound because it actually sublimes, which means it goes directly from being a solid to being a gas.
Okay, so as it melts, that's what we're seeing come out.
Well, it's not melting because it's not becoming a liquid, right?
I shouldn't even say that.
Yeah.
That's right. Learning so much so fast.
Yeah, and so you can see the color is ever so slowly changing here. And we started out at purple, we've now gone to blue.
Yeah.
And in a minute, we'll go to green and yellow as well. Yeah, it's going to take a minute.
Okay.
So, while that's bubbling away, why don't we have a little more fun?
All right.
Okay. So here, I've got...
looks like some sort of streamer or ribbon.
And that's exactly what it was. And it actually read on the package, non-flammable.
Aha.
That's no longer the case.
Because you chemistry genius, you've changed it.
Yes. I've installed extra nitrogen and extra oxygen in there.
Okay.
So now it's going to burn extra fast and extra clean. So we're not even going to see any smoke.
And you're going to burn that?
And we're going to burn this.
Go ahead. And you're going to hold it. All right.
Not for very long.
Whoa! That was awesome. I felt the heat.
Yes.
But there is no smoke and very little ash as well. It's just gone.
Gone.
Why is that?
Because with the extra nitrogen and extra oxygen that's in the paper now, it burns faster and cleaner because it doesn't need to get oxygen from the air.
Isn't that amazing? Some of the things you learn, and again, I want to remind people really quick because we're out of time. Where can they catch these Chemistry Magic shows?
On the Carleton campus in Southam Hall.
Okay.
And you can check out our website.
11 and 2:30. That's tomorrow. You got to check it out. Big kids and little kids alike. This is very cool stuff. And when we come back, we're going to show the changing color, I think, here, right? Oh.